Alright, so we're picking up in Chapter 5. We were on the lottery example. We never finished it, so we're going to have to finish this thing real quick. Okay? I happen to have it right here. We had an issue last time. Don't remember the issue we had? Well, let's look at what the issue was.
We didn't get to fix it, though.
Right, we didn't get to fix it because we ran out of time. But well, the issue is right here underneath this clean my filter. Alright, the issue is, it's basically saying possible loss of position, found double required integer. Well, to fix this, what we need to do is we just need to tell the random to return an integer. That'll fix our problem. We don't need those braces. So if we do that, that's going to fix it. Because integer.max value is obviously an integer. So we're just telling random to return an integer as well, and we're doing good. Possible loss of precision means we're going to be truncating it somewhat. So that first part's fixed. Now we're on to the second part. Okay, the second problem was something we got to fix down here. It says if winning number is equal to input. Now winning number, let's look at winning number. Winning number is what data type? It's an integer. Okay, so can I use this with an integer? Sure, I can. But the problem is with input. What data type is input? Input's right here. What are we getting input as?
String.
Getting as a string. So what we're trying to do is compare an integer with a string. Not a good thing. Well, we learned about some of the wrapper classes. And in particular, let me go back to one here. It's right here. So which type of wrapper class do you think that I can convert an integer to a string? Anybody? Looking at the bottom, the right hand side. Just want to go number to string. Is that what we want to do? So the integer wrapper class, okay? So the integer wrapper class right here allows us to convert a string to an integer and also from an integer to a string. So if I want to convert that to a string, all I have to say is integer dot to string. Now winning number is now a string. But is this the correct way of doing the dude here? So let's do dot equals. Now I should be comparing them. Everybody understand what I did there? Okay, remember, winning number is an integer. Our input was a string. Now I could have made our input into an integer, but I don't want to. You'll see why here in a minute. Okay? So I needed to convert winning number into a string so I can use the wrapper class. See, these wrapper classes are very awesome. We mentioned at the beginning of this chapter, that's what I forgot to bring up here was the GUI part for you. Darn it. I
Almost
got it right here. GUI and problem.
I totally forgot to bring the GUI up. Darn it. Sorry about that. I'll remember that next time.
I bet you $5 once.
Someone remind me so I don't have to pay him $5. Alright, man, I knew I was getting something else because I was even sitting down in my office. I'm like, sweet, I got the random problem fixed, and I forgot something else. Alright, well, let's see what our program does first of all. Let's run this thing. Okay, want to win $1 million? If so, guess the winning number. A number between. Wow. So what number do you want me to pick?
2.
2. We might be here all day.
It's a good guess, though.
How about 3? We missed 1. It could be 1. Could be this number. It's not working. Well, obviously we ain't never going to win. That's like the lottery. Assuming no one here plays the lottery. You notice you never see a rich person buying a lottery ticket? Why is that? What? No, because it's a waste of money. I've never bought a lottery ticket in Oklahoma. I was actually telling my previous class this. Robbie heard this, but my son had a foolproof way of winning. He said, "Oh, Dad, I can win every time." Yeah, I said, "Fine." He had $20. He didn't win a darn thing, all $20. I said, "Yep, your foolproof plan is working. It's to give them your money." So, all right. So let's look at this code. what's this? What the heck is this? Well, let me run this. For my input, I say, give me a hint. Try 0.
It's quite a hint.
Whoa, why is it 0?
There's a 0 chance. Nope, 0 again.
Something's wrong with our number. And I do not know what that is. What's the odd? Whoops. I mean to hit enter there. Give me a hint. Try winning number. Okay, winning number is coming up with 0. Why is that coming up with 0? Let's find out. When. Yeah, I couldn't spell it. Alright, what's going on? Math at random times integer at max value. That has to be correct. Hold on. I know something that might be able to tell me. What am I missing? Darn, this one's killing me. It's exactly correct. Oh, I do have to have the parentheses. My fault. Darn it. You do have to have them. I forgot. This will fix it. There we go. Alright, so let's quit. My fault, I missed the parentheses. Ugh. What was happening was I was converting this to an integer. So I was taking a random number. What is random return? Does anybody remember? It's a number between what and what?
0.
Between 0 and 1. And if I convert that to an integer, what do I get? 0. Then what I needed to do was multiply times max value first. My fault. Totally overlooked that part. But yeah, math at random. Actually, you know what? Let's show you guys what I'm talking about here. I'm just gonna output a random number. Okay. Having a hard day today. Feel like I'm on the verge of getting the flu or something. All right. See the number it returned? Let's do another one. Make sure it wasn't a fluke. And see how it's always between 0 and 1? Then if I put int in front of it, it's going to convert that to an integer, which truncates it, so it becomes a 0. Alright, so now we know how to... We got that fixed. Let's run this thing. Give me a hint. I'm guessing, but I'm going to try 17117381991. You're going to try that one, weren't you, Terry?
That's exactly what I was thinking.
Yeah, let me see if we win. So pretty simple to do, but let's walk through the code and see if it really does. Make sure we understand it. Alright, starting at the top, y'all know what the scanner class does? Allows us to get input. Then we have our class name. And I'm using the same file over and over and over. You can call it whatever you need to. Public set void main string bracket args. That's required every time. And this allows us to get input. Okay. Boy, this should all be indented more, but I don't want to go off the screen. Alright, and we're creating something for input. Then we're saying winning number is equal to all this stuff we just played with. Then it says you want to win $1 million? If so, guess the winning number. Then it says a plus number between 0. What's all this stuff? Anybody? What's all that? Anyone know? What's this character? It's not a plus sign.
Okay.
Concatenation character. Basically what he did was he's outputting this string right here. If so, guess the winning number, parenthesis A. That's the end of the string. Then he says, now concatenate that with this next line of space number between 1 or between 0 and. Then he's taking integer max value minus 1. Okay? And then the other bracket. So he's just adding the strings together. So that's how we got the output on the screen where it says, want to win $1 million? If so, guess the winning number, a number between 0 and 214-748-3647. Parentheses, period. Okay? Alright. Then he's telling us to input some money. He's got this inside of a do loop. So is a do loop a pre-test or a post-test loop? What do you think? It's a post-test loop because we're going to do it at least one time. So would a do-while loop be good for things like calculating interest on a savings account? Probably not. If you want to see if you got money first, that would be kind of a good option. Okay. So a do loop is a loop that runs and then checks. So we're going to run this first, and then we're going to, ask if you want to continue. Okay. So inside here we're going to have put, please insert $1. Then if our number equals, give me a hint. That's that part where I typed it in and it says, try this number. Okay. Else, if the input is equal to a Q, in other words, you want to quit. Okay. So in other words, if it equals the hint or equals a quit, okay, so it's not equal to quit, I'm sorry. If it's not equal to a quit, since we have the not there, then we're checking if the integer to string, which we just did, winning number is equal to input. So we're checking to make sure they're the same. Then we say, you win. Then foot is Q, force it to quit. In other words, once we get it correct, why do we need to go again? Else output, sorry, good guess, but not quite right. Then it goes again. Okay. Thank you for playing, come again. So, everybody okay on how that works? Pretty much get an idea? Okay.
You have a while with nothing else?
The while pertains to the do. This while goes with this do right here. Yeah, that's the do starts up there and ends at the while down there at the bottom. Yeah. All right, let's continue on. All right, so let's go back to. So we talked about the lottery example. We did that. Now let's talk about the character class. We've done some of this already. Now your program 5, which we're going to be talking about next class period. Majority of the class period will probably walk through some examples of these, so you're good to go there. But where's the clock in this room? We don't even have a clock, do we? Wow, lucky I have Mickey Mouse in my arm.
Say 15?
No. Alright. Character classes perform character-related operations use the character wrapper class. Just like the integer wrapper class gave us the ability to do integer to string, integer, parse int, such and such. The character class gives us options. Okay? Here's some of the more popular ones. Again, there's more than this, but here's some of them. Is-digits. What do you think is-digit can do? Check if it's a digit. What are digits? Numbers. Exactly. So if I ran, actually let's walk through an example of a couple of these. Okay, I'm going to change our program here. I'm going to say enter something. We don't need that anymore. We don't need that anymore. We need that. Okay, we're going to put stuff in here. That's the whole point of that one. Hopefully we got it all about right. If I can get it to tab over quickly. Alright. So, is-digit was one of them. Okay? So what does is-digit require as an argument? Does anyone know? Requires, what are these inside of here?
Characters.
They're characters. So it checks if a given character is a digit. Okay? Actually, I'll change this to a character so we don't have to worry about that. Actually, no, we'll just leave it a string. I'm going to say char equals. See? There we go. Now we're getting the first character. Oops. Missed something. I got to change it to. We'll say input 2. What? Oh, I didn't give it a name. Hold on. My fault. Input 2. That's better. Yeah, I had to give it a variable name, and I was trying to use a name similar. So input, actually, let's make it so it's easier to understand here. There we go. That'll solve the problem. Now I have a variable called input. which is going to get a line and store it in a string called input. Then I'm saying take that input, get the first character and store it in input 2. Then we're working with that. Okay? So let's see what this does. So if I enter a 0, it's true. Is the 0 a digit? Sure it is. Let's enter a K. False. So could you use that to check a string and see if it's if there's a character there or a digit there? Hey, you can go through a string, you can check each value and see if there was a digit there. Okay? Alright, let's try it with a special character. False. So what's the only thing that returns true? Is the numbers. These guys here. Okay? We also got is letter. Is letter checks A through Z, upper and lower case. So you could use is letter. Okay? Now we have an is uppercase. So with a capital C, it says true. Everything else it says false. Everybody follow me there? And is lowercase, a lowercase letter will return true. Everything else will be false. Let's do one of those. Let's do is lowercase. Let's do is lowercase. All right. So now I'm going to enter something. Okay, let's enter a 5. Should be false. False. Let's enter a false. Let's enter a small a. True. Are we okay on is lowercase? So if you had to check, in this section we're working on right now is 90% of your next homework assignment. Serious. This one little section. Because what do we have to do in our when y'all want to your next assignment's about passwords. Okay, anyone ever have to put a password in something? Like on Windows, you got to have an uppercase letter, a lowercase letter, and a number, or a special character. You have 3 of the 4. So could you use stuff like this, you think? Heck yes, you could. You could very easily check for an uppercase letter, and a lowercase letter, and a number, and a special character, and all that stuff. I decided to just ask for a little bit more than that. All right. All right. Is everybody okay on those? The character wrapper class? So far, so good? Okay. Let's look at the next one. Is letter or digit? Maybe I want to see is it a letter or a number? Okay. So we can use that. Or is white space? White space could be anything that doesn't print. It could be a space, could be a tab, could be a new line, could be anything that doesn't print. Okay. A blank, a tab, or a new line. Okay. Then we got 2 uppercase. Let's see what that one does. Okay, now I'm going to 2 uppercase. Okay, so I still got everything the same. I'm getting input for something. I'm going to convert it to uppercase. Okay, I'm going to enter a 2. I still get a 2. Well, there is no uppercase of a 2. Let's enter a capital W. Still a capital W because it's already uppercase. Now let's enter a lowercase w. Oh, it converted to an uppercase. Let me show you so you really believe it did it. Let's go small l, big L. There. Yeah, now you believe me. I know the W was kind of hard to tell.
A little bit shaky, yeah.
Yeah, a little shaky there. I'm sorry. Here, let's do another one. Yeah, you can tell. Or the ultimate. Obviously, y'all believe me now? Or we can do this one. If you're not totally sure, we can check the Y. Yes. See, it lost the little curvy part at the bottom. Chopped it, baby, right off. All right.
I need glasses so it still looks curvy on the back.
Sorry. It doesn't. All right. So we got 2 uppercase. We can also use 2 lowercase. Okay. We could actually write these methods ourselves, but they're already here, so we're not using them. All right. Great. Write a Java statement that updates CH's value so that CH get the uppercase version of its original value. Okay, so let's do that. So I'm going to call this thing CH. Actually, I'll call this one CH. And I'm going to say what am I trying to do here? Let's make this one CH. Will that do it? Hold on, let's find out. Now, what are we supposed to be doing with this thing? Oh, change it to an uppercase of its original value. Okay, so let's do this. So we want to go CH is equal to. So how can we make it take what it has and convert it to uppercase? Anybody? Okay. But I really need to use this phrase. See if it works. Alright, what do we use for getting input for a character? It can't be next char, is it? No. Yeah, but you can't get input for a character? I always thought you could. Maybe you can't. Okay. Maybe I'm wrong. For some reason I thought we could. There. We'll just do it this way. We'll do it the boring way. I thought there was another way to do it. I swear there was. There. So we're getting input for a string. Then we're taking the character. So here's our input for a string. Then we're saying CH is equal to the first character. Then we're going to convert to uppercase and output it. And I missed a semicolon. Okay. So if I enter a small a, I get a big A. Everybody see that? If I enter a big W, I still get a big W. What if I enter a letter or a number? Doesn't change it. So everybody see what we did? We got input for a string. Then we got the first character. Then we're saying CH is equal to character.to uppercase CH. So we converted whatever CH was to an uppercase version of itself, stored it on top of itself. So we overwrote its value. Because what happens here, okay? Remember, this gets the value from here. Okay? Then we take this CH and we do whatever this stuff says. So we convert it to uppercase and then store it on top of itself. So we no longer know what it was originally.
So we take the input, change it, and put it back on.
Yeah, we store it right on top of itself. Yep. Easy enough. Alright, then we output the screen. Okay. Oh, did you already do it? Program checks the user's entry to see if it's a legal identifier. Well, this is a pretty... Let's walk through this one. Let me bring this one in here real quick. Can't see that. That's top secret down there. We are looking for this guy. Okay, all we need is the main method. Okay, so let's wipe out all this. Put that in there. And we get the other half of it. I just don't feel like typing it all. Alrighty. Alright. Programs though. Let's see what this program does before we run it. Let's walk through it. Everybody okay on what this line does? Allows us so we can get input, creates a new instance of the scanner class. Now create a new variable and another new variable. What's this one doing? It says, is entered line a legal identifier? Basically, we're creating a variable called legal, which is either going to be true or false. Okay? And we're setting it to true initially, because we're assuming it's going to be correct. Okay? Then the program checks the validity of a proposed Java identifier. Enter a proposed identifier. Okay? Then we're going to get input for it. We're going to input for the next line and store it in line. So whatever I enter on the screen, we're now going to store it in line. Okay? Then we're going to check the first character. Remember we talked about identifiers back in like chapter 2 or 3 or something? There was certain letters you could and could not use at the beginning. So we're saying if not character.isLetterCH. So what is this doing right here? This part. What's it going to return? First of all, true or false, or what does it return? What does isLetter return? It returns true or false. Basically, it's checking to see if it's a letter. Because we got, so this checks if it's a letter, or if it's a dollar sign, or an underscore. Everybody see that? So, if it's not one of these things, so if it's not a letter, or a dollar sign, or an underscore, so if it's not one of those, it's false. So, okay, if I enter an A will be here. Okay? An A would definitely return true here. So it's not gonna. So it's gonna, not be true. It's gonna be false, which means it'll skip that first section. Now, it's kind of weird the way they wrote that, but it's all right. But we're checking to see if it's not a letter, a dollar, or an underscore. If it's not one of those, legal becomes false. If it is one of those, we just leave it alone. We consider it being good. Okay. Then we're going to go through the whole thing, starting at 1, going to length. By the way, this would be a very good template to use for your next program, because you have to go through something line by line and check everything. Okay? So starting at 1, going to the length. Why didn't we start at 0? If we're working with a string, doesn't string start at 0? Why are we starting at 1 right there? Anybody? Could be that we already checked 0 up there. We already checked 0, so why check it again? Alright, so we're starting at 1 then, going to the length. And legal. Wow, we've never seen this before. This is the conditional statement here. If I is less than the length and legal. In other words, if we're still good, we're going to go through this string, we're going to be checking it character by character. If we still got more to check and we're still legal, we're going to continue on. What are we going to do each time? Well, we're going to save each character. Remember, I starts at 1 and goes to 2, goes however long the string is. So, for each character, we're going to save out the character. Then if it's not, again, we got that whole not thing going here. If it's not letter or digit or dollar sign or underscore. So pretty much we're accepting more stuff now. Initially it has to be a letter, but now we're doing letter or digit, so it can be a number or a letter. So if it's not that stuff, it's false again. Then this is if legal. With Boolean items, you can just ask that question, because remember, Boolean stores true or false. So if legal, so in other words, we're still true. We didn't meet one of these false categories up here. So if it's still good, congratulations, we're good to go. Else, sorry, it's not a good identifier. Let's run it and see what it does. All right. So I'm going to enter name. Name is a legal identifier because it starts with a letter, dollar sign, or underscore. Okay. Now let's run it again. I'm going to say first name. Okay, now we have a letter at the beginning, so the first part's good. But the second part, remember, it had to be either letter or digit, dollar or underscore. I have a space between it. Y'all see that? Sorry, first name is not a valid Java identifier. Everybody see that?
So underscores mean like space?
Right, I put a space here, and you can't, no, underscore and a space are two different things.
Yeah, but
Let me do it this way. First, name. Now that, what do you think? Will that work? Sure enough. Because remember, we can have letters. For the first position has to be a letter, a dollar, or an underscore.
oh, okay.
The second through the ending has to be letter or digit, dollar, or underscore.
So when it saw the space, it didn't.
Right, didn't like the space. Didn't like the space. All right.
Yeah, the whole not care. The whole.
Yeah, the whole not thing kind of just throws you off.
Yeah.
It's tough, but it's just the way it is. All right.
Look up.
Now let's talk about the string class. We've mentioned a few. We've already done char at, length, equals, and equals ignore case. But there's other stuff we can do. Okay? So the string class is defined in the lang package. The compiler automatically imports it. Now let's present a couple more popular items. Substring and index of are amazing. Okay? Substring returns a portion of a string. Okay? Now, I'm looking at the first one up here, the first red bullet. It says substring. It says returns a substring that is a subset of the call and object string starting at the beginning index and going to the end. So, substring, let's try it. Let me go modify this program again. And let's get rid of a bunch of stuff. Actually, we need to get input, don't we? We need input. And we need to output something. So let's get rid of most of this, and we'll do that. Alright, so enter a string. Okay, get an input for it, then we're going to output something. Okay, we're going to output line.substring. Now I'm going to say 3. Okay, what that's going to do is it's going to print out whatever I enter starting at the 4th position. Why the 4th position? What's
0, 1, 2, 3.
Alright. So I'm going to type in, actually let me change that a little bit, just so we can make sure what we're getting here. There. Okay, enter a string. We'll say horse. So are we going to get an R, S8, RSE, or SE? SE. So this is starting at position 3, which is really the 4th. Because remember, H was 0, 1, O is 1, R is 2, S is 3. So when I said starting at 3, it went from the S and gave me the end of it. What if I entered something shorter? Hi. Whoa, we got a problem. Because I told it, hey, I want starting at position 3. And it's saying, whoa, index out of range. In other words, there isn't a position 3. So what if I say, this is a test to see if Terry is listening? So we get, this is a test to see if Terry is listening. Because it started at the 4th position. So it started at this S. So the T is 0, the H is 1, the I is 2, the S is 3. So it started at 3, which is the 4th position. And it gave us all the rest of it. So S is the test to see if Terry is listening. Easy enough. Okay. We can also use it a little bit different. Okay, we can also give the beginning index and after end index. This is the one that's tough. Okay? It says return the string that starts at the beginning and extends to the after index position -1. Okay. Let's oh, that's not what I want to do. Ah, wrong button. I'm going to run this, but I'm going to, oh, I was supposed to put a number in there, wasn't I? Let's put substring, let's say put a, 8. So I'm going to compile and run it. Now this time I'm going to enter 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So what should we get? We should start at the 3, shouldn't we? Since I put 8, is it going to end at 7, 8, or 9? So am I going to get 3 through 7, 3 through 8, or 3 through 9? It's the after index minus it. So it's the ending index -1. So it's kind of weird. I know other languages don't do it this way, but this way Java does it. So we told it to start at 3, and we said 8 for the after ending index. So in other words, 8 was past it, So it stopped at 7, so we only got 3 through 7. Everybody see that? What if I wanted to output from the 3 all the way to the end, but I wanted to specify an ending location? Anyone know how we could do that? Could we do something on this page maybe? Starting at 3, I want to go all the way to the end. Someone say something?
Length plus 1.
Length. All right, let's try length plus 1 here. So I could say line.length plus 1. Let's see, not 2, 1. Let's try that. Oh, let's put the dudes in here. All right, then we'll say this is a test again. What's wrong with it? String index out of range. All right, let's troubleshoot this. See what our problem is. Okay, first of all, let's output the length. We'll say line.length. Okay, I'm going to put in something we can do. Can do it. I can remember that. That's easy to remember. Okay. So the length is 9. Is that true? 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9. Okay? So when we said length plus 1, we ended up saying 10. So we said starting at 3, going to 10. But what are the valid indexes of my name? Is it 0 through 9 or 0 through 10?
So don't need the plus 1.
Okay. Let's take off the plus 1 and see what it does. What happened is there's 9 letters of my name, and when we did length plus 1, we said 10. But really, if there's only 9 letters, it's 0 through 8. And the ending index, remember, it's before the ending of it, so it goes to 8. So
That's a screwy way to do that.
it's very weird. I know. I don't like the way it does it. I don't know another language that does it that way. It's always basically what it does is you tell it where to start and you tell it where to end, and it subtracts 1.
I mean, the C# one is completely different.
I know, it's totally
It's-
different.
it's-
This is the only one that's like this. I don't.
The number, that second number is the length of characters from the beginning point.
Right, and that's not what this one is. I know, it's crazy. I know, it's you just gotta live with it. So this first digit is where to start, and this is where to stop, not the number of digits. What Mike's talking about is in C# you can say 5, and it'll say from 3 to give me 5 more. That's not what Java does. Okay, I didn't write it. Okay, all right, we'll go back to where we were at. All right, it says beginning index and extending to the after end index position, not number of characters. All right, there's an example. Well, we kind of just did that. Well, let's see what this does. Okay, so it says system.println candid.substring 8. So if this is entered, what would we see on the screen? Anybody? If this first line, substring 8, what would we see on the screen? Come on, someone figure it out.
Cultivate our garden.
Cultivate our garden.
Cultivate our garden. With a space in front of it or no?
Yes.
No.
We got 1 yes, 1 no. So we got a 50-50 shot. I'm going to go with a no. Because we're saying starting position 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. So season 8.
So it counts the 8.
Right. It starts at 8. Now the next one says starting in position 3, go to the ending after it. So in other words, 16. I know it sucks. I don't know why they did that, but we got to live with it. So 3, 0, 1, 2, 3. So we start with must. 3. Oh, lost my thing. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we get must cultivate. Okay?
So whenever you have that, and like the second number, just remember to subtract 1.
Right, what it's saying is that is the ending. You know, there's one past it. I know.
Is that because of the 0 that it
Yeah, but
uses?
they shouldn't have to do that. I mean, they didn't for the first one.
Right.
So if we,
They didn't say beginning plus 1. I don't know why they did that. There's probably a reason for it. Whoever designed this probably liked it for some weird reason. Yeah, it's really, really, really. This is probably the one thing that is crazy.
so if we want the whole word, we got to pick the number that would be the first one after the word.
Right. If you want to get like must, we would have to say. So if we wanted we must, we'd have to say 0. 0, 1, 2, 3, 4, 5, 6, 7. So we'd have to do 0, 7. That would give us we must. Because that's the ending after it. What's it exactly? It was how'd they say it? If I can get the slide back. The extending to the after end index position. I don't know. It's after, in other words. I don't know. It's. I still don't know why they do that. That's the way it works. All right. All right. Index of. Okay. Maybe you want to find a position of something. Okay. It works good for phone numbers, IP addresses, that kind of funny. I know some people online will listen to this, but I signed a problem where. Well, I used to assign a problem where I gave them an IP address. Some of you might know what an IP address is. It's used for locating your computer on the internet. Well, it's just some numbers separated by periods. Okay, that's all it is. So you can use the index of to find the periods. Well, I assigned that problem to students, and they got so confused. I can't do this assignment. I have no clue what an IP address is. I says, who cares what an IP address is? All you're looking for is the periods between the numbers. They couldn't figure it out. So I said, you know what? I changed it from the word IP address to phone number. Oh, now they can do the problem, no problem. I'm like, it's like, I literally took the assignment, changed it to IP address, changed it to phone number. So now they're like, oh, I can do it now. I'm like, it really didn't matter. But it was funny. Now it's phone number. All right. So index of says returns the position of the first occurrence of the given character within the calling object. Returns -1 if not found. Okay, let's try that. Okay. Now we're going to output. We'll do line dot index of, say, an A. Okay. So we're looking for an A. Can Dewey. Do I have an A's in there? -1, not found. Okay. Try it again. Try to think. There. We have an A there? Sure we do. 0, 1, 2, 3, 4. So it does return the exact position. Now, because we were hard coding those values a few minutes ago, in the real world you don't do that because they can vary. Like on the phone number program, I tell them where they have to accept a country code. You all know what a country code is? Like 1 for the United States, or 001, or 49. No, it's 001 for the United States. It's 49 for Germany. If you ever spend time outside the United States, it's hard to remember, hard to dial those. You know, they're not all just like us. So, all right, but you can use index of to find stuff like that. Look for certain characters. And you can also use it like the second one, index of, for a certain character starting at a specific position. That's handy. Maybe you want to find the second period. Find the first period, then starting from the first period, go to the second period. You can go, or you can also use it with a string, or a string from index as well. Okay? I'm going to finish this up. Okay? Here's just an example, kind of what we just did. Okay? All right. There's also last index of. Maybe I want to find the last E. Let's change mine to last index of. Let me make sure I did that right. It's last, okay. So last index of. And we're going to search for an E this time. So if I type in Ken Dewey, what do you think we're going to get with last index of? So let's see. Are we going to get this one? That's 1. 2, 3, 4, 5, 6. This is number 7. So should we get a 7? It's the last E. Sure enough, we get the last E. So last index of returns the last position of a specific character. Okay? Okay. Oh, printf. Printf is awesome. Okay. It says formatted output with printf. You should strive to make your program output understandable and attractive. Okay? Printf is used for generating this stuff. Okay? Alright. And here is how it works. Okay? Look at the format specifier. Okay? Has a $sign, then a %.2f. Okay? The %.2f tells it how to format something. Okay? Or in this case here, what's happening is remaining 1 plus remaining 2 is added together, and that value is output right here after the $sign. Okay? You can have a whole bunch of them. Down here is an example. Some sort of text, percent, some more text, another percent, some more text. As long as you have the correct number of items at the end, see how we have 1% something here, 1% something here? You just need 2 items at the end. Okay? And let's play with one. Let's output a number. Remember the other day we were outputting pi? Anyone remember pi? Oops. Okay, let's output math.pi. Remember that? Well, I want to see pi with only 2 decimal places. Okay? Because that's too many numbers for me to remember. Well, what I can actually do is instead of print line, I can use printf. Okay? Well, now we need to tell it to do something. What are we going to do? Well, with printf, we got to tell it something in here. Pi, pi. Okay? Now, we need to use a format specifier exactly like they're saying here. A percentage, flags, width, precision, all that stuff. Okay? So let's do this. So we want percentage. Shh, don't make me look stupid. Blueberry pie. Alright, so now obviously we need to have something in here. %2f. Let's see what that one does for us. Okay. What I'm telling you to do here is, this is my format specifier right here. So I want to see 2 decimal places of a floating point number. And it's referring to this number here. So let me run this. Now I have 2 decimal places. You see that?
How come you didn't want to use the $sign?
Well, $sign is only if you want to. I'll put a $sign. Yeah, that wasn't a format. That's part of the text.
Oh, okay.
It's like they put a $sign here, like this one. Now it'll be $3.14.
Oh, okay.
Yeah, that's just part of the text. And now I'm going to make it pretty. Now I'm going to do a carriage return there. Okay, let's do a couple other things. Well, what if I want to make it a certain length at the beginning? I can also specify how long I want to. Actually, let me put the $sign back in there so we can see something here. Okay? Wait a minute. Oh, I know why. Hold on. That's what I wanted. I'll explain what that is in a second. The heck? 1, 2. There it is. Okay. This first part is how long you want it to be. Total length. Okay? When you put nothing there, it just defaults. It outputs whatever it needs to. So it did the 3.14. Okay? But if I tell it I want 5 places, 3.14 is 4 digits. You agree with that? Well, if I tell it 5, it's going to have to leave a blank space now. See how it left the blank space there? So if I change it to 6, I'll have 2 blank spaces. In other words, it's formatting the width of it. If you look at this slide, that's what they say, the width. Precision, that's how many decimal points. and then some conversion characters. Let's look at those. S is for strings, easy enough. D is for decimal integer. So many people, me myself, I screwed that up too. Okay, D is for decimal integer. I always try to put an I. Okay, F is for floating point, and E is for scientific notation. Okay, those are just the different things you can put in there. Okay, let's add another one. After this thing, I'm going to tab it over. We learned that a couple chapters ago. I'm going to put a %s for a string. I'll say. So what's going to happen is this first one right here, that guy right there is going to pertain to the math.py, and this right here is going to pertain to the name, the string name. So what happened was I did that with a spacing of 6. 1, 2, 3, 4, 5, 6. Then I tabbed over, and I got name. Tab is 5 spaces. Everybody see that? So I used a floating point, and I also used a string. Alright, easy enough. Okay, here's an example. This is going to output the word planet. Then it's going to have a space. Then it's going to output a string. And Neptune is going to be output right there. Okay, just like it is here. The next line, number of moons, they have %d for decimal integer and a carriage return. So the 13 is going to output right there. So we got 13. Orbital period in Earth years, saying %f, so it's a floating point. We're not specifying how many at this point. Okay, 164.79. And that's why we get all this. Then here, average distance from the sun in kilometers. This is scientific notation, and that's where we get that. So, okay? It's not too hard. So, all right. Now let's look at precision and width. Okay? Precision is the points, the number of periods. That's the 0.2 I used. That's this guy right there. Okay? It says, works in conjunction with F and E. If syntax consists of a dot, then the number of decimals are those to be printed to the right. In other words, the decimal places. Right? If the data item has more fractional digits than the precision, it rounds it. Obviously, pi had more than 2, so it rounded it. Okay. If it has fewer, then it adds zeros. Let's do an example of one with fewer. So I want 5 decimal places, but this time instead of math.py, I'm going to output 3.14. Okay? So what should I get on the screen? Actually, let me get rid of this 6. What should I get for this first value? Anybody? 5. So I have 2. So what am I going to get after the 4? I'm going to get some zeros. Because my precision right here said 0.5, so the decimal place and then 5. So there's my decimal place. I added the 2 that I gave it, and then I get 3 more. Okay? Alright, width specifies the minimum number of characters that are to be printed. If it's more than that, it will print more. Okay? Data contains fewer, then spaces are added. By default, output values are right aligned, so easy enough there. Okay, and here the cows are, and it's hard to hide the bottom parts, you can't see it, but cows are 6s. In other words, I'll put a string, but take up 6 spaces. So that's why there is 2 spaces in front of cool. Okay, but dogs, now we have 2s. So we're telling the minimum width, it has to be 2. But dogs is 4, so we don't do anything with it. Okay, pi equals 7.4. So the total length is 7. 1, 2, 3, 4, 5, 6, 7. With 4 after the decimal place. So that's why I get 3.1416. Okay, easy enough? It's not that difficult. Alright, flags allow you to add supplemental stuff. You can add dashes for minus signs, whatever. And you can add a 0, a comma, a brace. Here's what they look like. Okay. The minus signs for left justification. The comma will give you the comma separator for thousands and all that stuff. Okay. I'm not going to run this one, but actually it might be on the next page. No, it's not on there. But yeah, you can add those if you want. The examples in the book, you can walk through it. But we're almost running out of time. I just want to make sure we finish this. Okay. All right. Actually, let's look at something real quick. You notice how they have a string here? They made a string called heading format string, and then another string for data format. Then they're using them right here. There's the heading format is right here at the bottom. So the heading format is going to say left justified for 25 spaces, and it's going to put the word account there. Then 13 spaces for actual. Then 15 spaces, wait, did I miss one? Yeah, 13 spaces for budget, then 15 spaces for remaining. Okay? And you can play with this. You do not have an assignment in this, I don't think. All right. This is not the graded quiz. It's just a basic quiz. Let's see if we can do this. What is the name of the class that contains abs, min, and round? Anybody? I used it a second ago. The math class. Remember math.pal, math.pi, math.whatever. Remember the whole ABS, absolute value? That's a tough one. I think you might have that though. Okay. So the integer and character classes are examples of the Hoover class, the framework class, or the wrapper class? Wrapper. It's the Hoover class. All right, that's the end of this chapter. I thought there was another page, but I guess not.